Hey everyone. The title is introduced the transforming ML training at Coinbase. We used to use Sagemaker related infra, and we moved to Ray. I want to tell the story of this. This is Wenyue Liu from Coinbase. The content of today, we talk about the mission. That's the first thing in Coinbase, and then talking about ML, machine learning at Coinbase, how we transform the transformation with Ray, which we improve the speed, scale, and efficiency. Talk about how we do the migration, talk about the impact and the future. All right, the first mission in Coinbase, we are the Coinbase mission is increase the economic freedom in the world, and just translate to machine learning training platforms mission. We're focusing on improved MLE's dev velocity. We're making sure MLEs can build a scalable training model. We can improve the cost efficiency for our training system. Give you a short history of machine learning in Coinbase. Probably could be a story of any fast-growing company. We started with the first machine learning model in 2017. We're using this I think it's AT or user risk model, which is talking about if you should transfer money to this suspicious user, right? And then in 2020, which is the last bull run, we introduced a package called EasyML, which is helping our machine learning engineers build the model faster. In 2020, we also built our internal feature store. 2022, we introduced Easy Tensor, which is better suited for our recommendation system or model. 2023, we introduced CBGPT. As you can tell, the name is about GPT helping internal or external chatbot or internal tooling. In 2023 Q3 last year, exactly the same time, we joined Ray 2023, and we were interested in this tech, and we decided to move our train and serve from our in-house solution to Ray. And by Q2 2024, we finished everything on machine learning serving to move to Ray, and we just finished our training and batch prediction, migrate everything to Ray. We are also investigating how to use Ray for LLM fine-tune and LLM serving. That's a brief history of our machine learning system. Some use cases are predictive. We just talk more about predictive ML, but some use cases like logging ATO, say account takeover. If your account is stolen, as there are a lot of fraud in crypto area, but we try to block this. Fund transfer, withdrawals risk, and risk of external Ethereum and Bitcoin wallets. We also have some notification optimization. We have this assets you might interested in, asset you might like, or we also have something like related to CBGPT chatbot or customer service experience. Yeah, that's the overview of our machine learning. So go back to Ray and talk about this improvements or our achievements. We talk about three areas. First is the iteration speed or dev velocity. So in the Sagemaker-based area or the era, that go back to before we moved to Ray, we just realized this take you a lot of time to wait and then go to doing the iteration. So the typical flow here is the MLE, machine learning engineers, make a PR and then build a Docker and push it to ECR because SageMaker required to have a Docker image, right? And then once you have this built and have a ECR link ready, you can use this as a link to send to our internal service and then trigger a SageMaker training job. We just realized it's take you up to 2 hours to prepare this thing and then see how your job is working. That's super slow and it's just crazy. Sometimes people just think, okay, maybe I just work on the feature instead of work on the model, because who knows if my PR will work or not. And if I do 3 or 4 times, that's a whole day have been passed, right? So why it has like so long iteration time? First is because SageMaker requires, or at least our infra requires, to have a Docker image. Docker image is a very heavy component, and we think it should be as lean as possible, but Docker image is trying to build everything inside of it. But actually, when you are training a model, especially when you are having like 20 models running on using the same Docker image, you probably want to have a separation. So MLP platform maybe just maintain a small one, and then people can just use their own way to control like what actually to plug into this Docker image. But it's kind of impossible. So if you're looking at the screenshot or the picture, you'll see like in the Docker image, we used to have like model artifact, Python model code, right? We have all of the util functions. We have this pip install list. Everything is on it. We have the CUDA, we have the Python version, we have all of this information. But actually, what we want to do for machine learning training is actually a very simple one. Just Docker Python version, CUDA version, and some like AWS CLI, which is essential to move some data from S3. Other things could be added as a plugin at the runtime instead of like pre-built into the Docker image. That's the actual reason. And how to achieve this? Moving to Ray, we use this new workflow. So we can create a working directory with the training logic. If you're seeing the screenshot, you can call it basic ML, basic model.py, right? We can let you to build some local zip file or wheel files, and then we let you to write a config YAML file. Using our internal CLI wrapper, we can trigger the job using this information. Very simple, and give you an example how we do this. If you're just having a basic model, just like I said, it's Python, and you train a Titanic model, what do you need is just 3 files: a build file, this py file, and this config YAML file. And you can trigger it immediately, and in the snap, you can see this running on your Kubernetes cluster or the Ray cluster, And then after this model is finished training, we can push this model artifact to MLflow and then go to the serving. So give you a look of what the YAML file looks like. It's pretty similar to what we have for Ray YAML, config YAML file. We add this thing called py module part. We let you to build your local wheel file, and then add this local wheel file to send to remote, or we can use this PyNest, which our repo called PyNest. But basically, like telling, like, okay, what is the remote one, which is already checked in the code at, and then you can either use the remote one, already checked in master branch one, or you use your local branch one. So your local branch use your build file to build a local zip file or wheel file, and then submit it directly. You don't need to wait to say, okay, go through the whole loop, build Docker, and then go back, right, to have this ESR link to trigger the job. So it's super fast. It's just like if you don't change your code on this like wheel file or zip file, it probably just take you like a snap, like 5 seconds to trigger the job. If you do need this, then depends on how big your files are, but probably just take you 2 or 3 minutes because you eventually upload this wheel file, and that's the recluster understand it. Yeah. Another thing Ray can help, or Ray actually helped us, is the GCS. So instead of, if you trigger a job on SageMaker, you probably want to wait a little bit when say, okay, this is a Docker file, and then put the Docker file, create an instance, and then install everything, right, into that instance and start it run. But we have a long-running cluster, so most of our files are cached in this GCS. So that's why you can trigger the job within seconds instead of like you need to wait for installation of these pre-built packages. Yeah. So that's a before-after comparison. Before, we took 2 hours for a simple change, most of the time it's just waiting for a Docker build. Right now we use, if you need to make a code change, share the code change, you take 5 minutes. If you're just like local, your main logic change, you just get the result in like 5 seconds probably. Yeah. Another thing is about scale. So for Sagemaker, most likely a Sagemaker training job is using a single instance, and our system used to be very heavily based on Sagemaker training job, so it's always as a single instance. And we use some tree-based models, used to use some tree-based models for tabular data. The working flow is like this. We have the raw data, maybe from Kafka, from where, and then go to Spark, Snowflake, and then process, either dump to S3 or not dump to S3, pass it to a training job. And we do some last mile data transformation, say some one-hot encoding or something like that, and then go to machine learning model, XGBoost, PyTorch, or something scikit-learn, and then go to MLflow. The problem is single instance is like vertical scaling, not horizontal scaling. So definitely you cannot getting more like memory, more than maybe half terabyte of memory, because there's no instance available, right? Another thing is like, what if we just distribute your job on Sagemaker? I think the problem is like Sagemaker's distributed training is basically for tabular data. It means you need to use PySpark. So that means you need to build like two things. First is a PySpark to process your data, and then dump to somewhere, and then pick it up by a machine learning model like PyTorch. That's that's like not a single step. It's a multi-step scaling. And also when we were researching on this distributed job on Sagemaker, it doesn't support a tree model, which we must use before we might fully migrate to other models. So under this limitation, we're try to use instance with largest memory, which introduce huge resource waste, because the CPU and GPU they provide with this memory are basically wasted, because we don't actually need this. We just need this memory to keep our data, processing the data. What we actually need is horizontal multi-step scaling. Okay, so moving to Ray, the thing is like we use Ray data to read the data from S3 or data sharing. Data sharing is an open source protocol from Databricks. We rewrite this easy tensor to make this pre-processing and PyTorch training distributed. We also rewrite this last mile data transformation using Ray data's map bash function. So what we can do right now is we can use TB level of tabular data for training. We use billions of rows. Our data size maximum is like 50x than previous max. We use S3 and delta sharing to connect Spark and Ray, which Spark is for our data processing. We have cluster with over 70 workers, sometimes more. The last mile data transformation dropped from 120 minutes to 15 minutes because Ray data is distributed data processing. So actually we got a bottleneck here. Say when we are trying to read the data over 100 gigabyte from Spark or from Databricks, we realized, okay, we just call this we assume we can pass like 1 terabyte data from calling the API, but using this read Databricks table. But we realized the backend is sorted by this Databricks API. Only 100 gigabyte data can be passed. And we directly asked the Databricks team, is it possible to let us to pass like 1 terabyte data? They said no. It's impossible. So we realized, okay, that's a bottleneck. We must use S3, and then probably, when you are doing the dropping the data to S3 and read back to Ray, then you have a lot of resource waste. Maybe if you just forgot to delete the file, and you have like a terabyte data living S3 forever. So what we do, we introduce this Ray data read delta sharing table, this API. Just provide your your profile. I think this is called profile in data sharing, and then say how many rows you want. It could be, 1 billion row or whatever. We achieved this using this one, and achieved reading 200 gigabyte of data using the API within 2 minutes. It's pretty fast. The backend is actually drop it to a temporary S3 bucket and then read it back. So so on the surface using API, but the backend is actually using some reading from the disk, and you can use multiple distributed way to read this. So super fast. Feel free to try it. After 2.33 is available on Ray open source. So before typical cases, like we use this P3 16x large. A lot of GPUs, a lot of CPUs, a lot of memories, but very, very expensive. Right now, we go back to use G5 8x large, A10G GPU. So it's relatively cheap compared to before, and that's what we have. We did some optimization to use Datadog metrics, like logical. That's the concept of Ray, logic CPU, GPU utilization, to guide our Kubernetes to scale. For some reason, we cannot use Kubernetes, so we use this hack to use this logic CPU, GPU utilization to guide the scale up and down. And we provided a cluster with different CPU, GPU ratio for different cases. Sometimes, as a CPU intensive, you probably want to have a higher CPU rate. Then sometimes you just, more GPU as suit your case better. The last one is resource sharing and the cost efficiency. We talk more about this hyperparameter optimization thing when we're talking resource sharing. So if you see the graph on the right side, that's how Sagemaker or typical machine learning workflow use doing the HPO. So you read the data first, and then do whatever transformation you want, and then trigger a PyTorch or XGBoost training. Multiple jobs are running in parallel on different machine, and then you report the result to some like controller and see like which one is getting better performance, and then the worst one will be killed, right? Because you assume it won't give you a good result. But actually, think about this. Why do you want to read this S3 file 10 times or 20 times? You just need to read them once, do the transformation once, and then trigger 3 jobs in parallel. Right? That's how Ray Tune help us. So when we're sending a job to Ray cluster, we will use runtime environment to cache in previous job, which is So when we are doing the hyperparameter optimization, it means all this can be shared, and we don't need to run these multiple jobs together, and you can scale it when you are going to the training stage instead of like at the early stage you use all of the resource. Another thing actually for resource sharing is, as I said, we have the long running cluster. We have the scale up and down. The thing is, like when you are triggering a job on a single on Sagemaker instance or some other instance, you need to wait like 5 to 10 minutes to let it ready for you to trigger the job. But moving to this thing, you have all of this cached on the GCS, so you don't need to wait this long time. And one job's waiting 10 minutes, then what if you have multiple ones? That's all saving of your time and improve your efficiency. Yep, that's all of the benefits. Talking about the migration process and results. So what we do, we decompose our Docker image into multiple components and then pushing them to our internal pipeline. We set up this Ray Kubernetes Ray clusters on Kubernetes, and then have all kind of DNS, S3, private link, whatever connections. For a single instance model training, just say you have a job, you just want to reproduce whatever you have before. You just have this Ray int or Ray remote and give it moving to a single Ray task. right? And then run this read task inside of that worker node, right? And if you are, which makes your transition very fast because you basically just add a wrapper outside. And if you're thinking, okay, my model is limited by Sagemaker, I need to do horizontal scaling, then you need to reconstruct your data connection, like using array data, then rewrite your data transformation, rewrite the job using retrain. And for HPO, it can support both cases. The full migration took us like 3 quarters-ish. We finished everything, and we are actually closing our Sagemaker training job this week. Some challenges we faced during the migration. There are many, but first is how to scale, how to do this logical CPU, GPU job supervisor scaling. Basically, you don't want to kill your cluster or remove this instance. If you have like one single RAID cluster running multiple jobs, you don't want to reduce this number of workers while there is still 1 job or 2 jobs running. So you need to use a concept called job supervisor. Always monitor that one to see, okay, I only scale down when everything is done. Otherwise, you're just removing something saved in the memory, and then, that's a big problem because you cannot reproduce things. Maybe you cannot. And using this logical CPU GPU, which when you are having high logical CPU GPU, that means you need the resource and you need to scale, right? We have this problem of reading data from Databricks, so we resolved it by introducing array delta sharing. And also the MLP and MLE ownership separation. Before, it's like everything mixed together. Right now, MLP only maintains this RAID cluster and the base Docker, and MLEs are responsible for all of this customized code and your package. Like, you need to resolve your version conflict. You can override something, but you need to make sure your code and your pip installed package versions are aligned. We also introduced some job status notification. So when you trigger a job, once the job status change, we're just always ping this job, and this status changed, then you got a notification, either email or message, Slack message, so you can fast iterate and just monitor your job. This is a summary of what we have speed-wise from hours to seconds, size 50x billion rows TB data, cost, we are sharing the resource, and even the instance cost dropped by 20% because of the surcharge. This is our chart from MLflow. I made a screenshot. So you see, like before, you see like because of introducing our HPO, we have a significantly high number of model training compared to before. That's the benefit of using RAID. We used to have HPO like setting using Sagemaker, but that's super expensive. And we never use it because someone would just come and find us, say stop, that's too expensive. And further improvement, future improvement, we're doing the test at the job level, but not the task and actor level. Eventually, people, MLEs want to just take a look at this actor's improvement, but you don't want to read the data and wait for maybe 20 minutes to process, or maybe whatever minutes to process this. You just want to pinpoint on this task or actor. The CPU, GPU efficiency utilization monitoring, and this clusters further scale up efficient CPU, a number of CPU and GPU setting. We just need to provide some guide to our MLEs, say you need to maybe reduce your number of CPU to a fractional, maybe 0.1 instead of just using 1. And also add this LLM fine-tune support. This is a term we use today, ATO, ECR, things like this. That's all about what I want to talk about today. We are hiring MLE, MLP roles, and we got a lot of support from Recore, Redata, Retrain community, Rahul, Jiajun, Matthew Deng, Cheng, Justin. They provide a lot of feedbacks and guide to us. Yeah, that's all. Yeah, any questions? Oh, yeah.
So do you also use Ray for serving the model?
The question is, do you use Ray for serving? Yes, we moved our machine learning serving to Ray in Q2 100%.
That makes a lot of sense. And also, I know there's, in my experience, that there are different model training purposes. Like sometimes you just want to try new model. Sometimes you have established the pipeline, just retrain model with some different config, with some new data. Like this platform, is that more for the first purpose or second purpose?
The question is, this retrain platform is for like experiments training or some like reproduce and retrain thing, right? We don't separate this. We all use the same CLI or command to trigger the job. It more depends on how you write Airflow DAG or something, or how if you want to train from local or train from Airflow scheduled job. We use MLflow to control which job can be used to for batch prediction or for production serving. Sorry.
Sorry if I missed it, but where do you publish like trained model artifacts when you're done with like an experiment?
The question is where you publish train model model artifacts. We publish to MLflow, internally hosted.
Yeah, I was just curious. You said that for your Kubernetes cluster tuning, you use Datadog metrics or something like that. Could you elaborate?
Yeah, the question is, are you using Datadog metrics to guide the Kubernetes to scale, right? Yes, we do. The reason is because we have a layer built on top of EKS, the company infra layer built on top of EKS. So you cannot directly touch EKS, but you must go through this layer. And this layer actually have this Datadog agent to monitor all of our EKS clusters. So yes, and then we add some customization, collaborate with our infra team to say, what is this, some customize. Well, so we actually pushing this log data, this metrics to Datadog, right? And then when we are guiding this cluster to scale, we can use this custom feature back to what's called HPA, horizontal pod autoscaling. So that's a collaboration. Yeah. This one.
Good question. So I remember like you quickly talked about the migration works. So how many kind of there were used to be and on the platform, and then you do microservices to migrate all?
Do you mean like how many engineers in my team to help this?
How many talents there used to be on your platform? I assume
Talents?
Yes, there might be like different teams on your platform using the Sagemaker to be training. So, so how do you do migration for all of them? Like, do you have all the experts, or is it more like white glove services?
The question is how many models or engineers are working on model trainings. We have 10, 15-ish engineers working on the traditional ML models. How we achieve this, I said if you just need to reproduce your model, what you need is basically add a radar remote on your outside of your model, right? That migration is pretty simple. But if you want to have your model performance better, then you need to rewrite your code. So we just ask them to move because the cost is so high. Yeah. Yes.
Did you hit any bottlenecks in migrating the last mile transformations to Ray data? Like maybe some operations weren't as performant as they had been previously?
The question is, do you have any bottlenecks moving your last mile data transformation from Sagemaker to Ray? There are a lot. So we have a couple of hundreds of last mile data transformation functions. They're not implemented the same way. So most of them are similar. So I myself rewrite most of them myself. Try to, for map batch, you need to make sure it's like always using pandas or NumPy to do this because of vectorization. Rewrite them and then set up an example. If you have something you want to migrate, then for large models, right? You need to rewrite your leftover functions. But that's a lot of work we have done on this migration.
You mentioned that when you move to Ray, you don't need to do any PRs. You can just submit the job. Can you elaborate a bit on that? Does that mean there is no controls? I can just push it into production, or was there a different system before?
The question here is because we removed this PR request, is that possible we just push whatever model, whatever things to production? Actually, no. The reason is we used to use PR to front load the control, right? But when we are moving this, security and convenience is always conflicts, right? So we move this control to the ML flow layer. So you can drop a lot of things to ML flow, but when you are deploying through Ray-serve, you must get a PR, and you must show me this link and show, okay, this is triggered from a production pipeline instead of from your local. Does that make sense? Yeah. Oh, question.
So the pre-processing on existing data set makes sense. Did you guys also leverage the Ray data pipelines to build derived data sets? Something to persist and sort of use for the future?
The question is, do you persist some of your data transformation thing? We do some of them, but not at the data transformation part, because you read the data and based on the reading, you process it. But we do some encoding persist. So say you transfer your model is using some special encodings like text encoding. You only train once and then you dump it to S3. So next time you're training this one, you pick up this artifact or this weights, something like that, and then go back. You don't need, and you just fix this parameters, this portion of parameters in your model. So that's even speed up your training pipeline.
Quick follow-up on that one. Is that because compute is like not something you're like trying to reduce? So like if you have pre-processing, if a model needs to be trained like a bunch of times.
The follow-up question is, can you repeat your question? Sorry.
I was just like preparing the data and having it saved from, I don't know if it's like a long list of coin charts, stock ticker chart data or something like that for your model to be used. It seemed like a design that would be easy to implement with pipelines.
I see. The question is like, do you keep this data pipeline on Ray? Most of our data processing is actually either on like legacy ones on Snowflake, and we moved a lot of them to Databricks. Your processing is on Spark, and then use data sharing to drop that. The question is why you move from Snowflake to Databricks. The reason is not first. The Spark is we think Spark is faster, and we wrote many low efficiency SQLs on Snowflake. But I cannot speak too much on this. This is another part of this work. But another reason is we are using a feature store vendor, which help us to move a little bit more on feature store, and they have a lot of features, features from this vendor. Yes. I think the question about the slide now. yeah, maybe if you have a question, just drop here. Yeah. Right. Thanks.